going really, really slow.
So today we're going to start working on chapter 3.7. Okay, chapter 3.7. Okay, and we're going to, this is going to be called Solve Systems of Equations. Solve Systems of Equations by graphing.
Graphing.
Solve systems of equations by graphing.
Wait, what are you writing it? Facebook?
Solve systems of equations by graphing. Okay. So, does anyone know what a system of equations is?
Nope. Something that's working of numbers.
Yeah, not exactly. Okay, a system of equations just means more than one equation. Okay, so more than one. So a system would mean like more than one equation. So sometimes it could be 2, sometimes it could be 3, anything like that. Okay, so systems means more than one. Okay, by graphing. So basically what we are trying to figure out is if you make graphs like this. Okay, I'm going to show you 3 different types of graphs. Okay, 3 different kinds here. If I gave you 2 lines, and I'm going to draw them for you. Okay, what we're going to be dealing with today is mostly when we have 2 lines. So if I gave you, if we graphed, okay, and you had one line that looks like this, and one line that looks like this. How many answers do you think that this has? When we're finding, when it says solve systems of equations, what we're trying to figure out basically is where do these 2 lines cross? So how many different places do these cross? 1. So in this systems of equations, we would say that there is 1 solution. Okay, that has 1 solution because the 2 lines cross at 1 point. That is how most of your equations will look. Okay, that's how most of these problems are going to look. Sometimes, though, you're going to have equations that look like this. Okay, where one is going like that, and one is going like this. These are called what? Parallel. Good, you guys knew that. I wasn't sure if you knew that or not. I don't know what you guys did in 7th and 6th grade, okay? So, parallel. If you have 2 parallel lines, how many times do you think they cross? Never. So this would be how many solutions? None. No solution, right? Okay, no solution. So if your lines never cross, if they're parallel, that means they would have no solution. How do you know if 2 lines are parallel? Does anyone know?
They never touch.
They never touch, okay? But how can you tell that they're never going to touch, like, really, really far away? Court? You could, sometimes they're designated by the little arrows that say they're parallel.
They're at the same angle?
They're at the same angle, okay. They do have something in common, but does anyone know what do they have in common?
Their number, the coordinates they're on are...
Not quite the coordinates, but what would they have in common? So basically, you're telling me each one goes up and over the exact same amount, right? Up and over the exact same amount. So what would that be called? The same slope. Same slope. Okay, I know, but I was just making it louder. So if 2 lines have the exact same slope, they will never touch. Okay, that makes them parallel if they have the exact same slope. Okay, and then the last type of situation you may see is if you have a line like this, and your second line is like that. They're basically the same line, right?
Yeah, but one is shorter.
Okay, well, one is shorter. I did that on purpose so that you could see that there was 2 different ones. How many solutions do you think this would have?
2.
How many? Whoa, let's think about this. How many places do they cross? Do they just cross at 2 places?
9.
No, they cross it. They only cross it one place?
Wait, they didn't cross at all. They're the same line.
It is the same line, but sometimes you might have two different situations. Hold on. Well, you don't count them, because even on a grid, if you have the exact same line on top of each other, it crosses in how many places? Can we say how many places?
No.
All of the places. So this means if you have basically the same line, it has an infinite number of solutions. Okay, so this is infinite.
So it could be any number?
Infinite solutions. That means you can't count that high. Okay, infinite solutions. So we are going to see three different ways here. Okay, or three different possibilities. You could have one solution. You could have no solutions if the lines are parallel. Or you could have an infinite number of solutions. Okay, and that's basically the exact same line. So what we're going to do is the first part of your homework is going to ask you, let me write this down correctly, okay, it's going to ask you to, it's going to say solve the system by graphing. And what that means when it says solve the system, what that means is find where the lines cross. Okay, find where the lines cross. And for example number 1, I'm going to give you the lines. I want you to find the crossing points of the lines. Sorry, I lost my place here. I'm going to take that one. I'm going to give you one that's like a really good one. Solve the systems. Let's do y equals 1/2 x minus 6 and y equals negative 4x plus 3. Solve the system. Y equals 1/2 x minus 6 and y equals negative 4x plus 3. So, if you have a colored pencil or a different color pen or anything like that, I would suggest using it, okay? If you need one, I have a bunch of colored pencils that I will let you guys borrow if you want them. Hold on.
They can be ugly.
Okay. So, if you need a different color pen or a colored pencil or something, you only need one other color, okay? So, if you need to, you can borrow one from me, okay? So,
can I use one of these?
So, what I want you guys to do is everyone come get, actually, I'm sorry, Megan will bring around a different color for each person. No, because you need to write things down.
I do.
Okay, so if you can just give them all one colored pencil, okay?
Can I get a pen?
No. So, all we need, so what we're going to do is we're going to have two different colors for our lines. The first one's going to be like a pencil, and then the other one is going to be an actual, excuse me, a color. Okay, so you're going to, I would just put a dot next to each one. Okay, put a dot next to each one. Guys, hey. Listen, please. Say again? I didn't understand
What you
what you
say
said.
do the color dot and then...
So I want you to put a pencil dot next to one equation and a color dot next to the other one. Put a pencil dot next to one equation and a color dot next to the other one. So you know which one is which. And we're going to draw two different lines. Okay? Hopefully, listen. My turn, guys.
I have grid paper.
I'm glad.
You want one?
No thanks. I'm good. Thank you. On your homework, listen, on your homework, you guys have the grids. Okay, so on your homework, you will have the grids. Right now, for notes, I understand that you don't have the grids, so do the best that you can. So, what we are going to do is we're going to figure out where do these two lines cross. So, for my pencil line, where do I make my first point? Where should I put my first point for my pencil line? How do I graph this? Y equals 1/2 x minus 6. do you remember y equals mx plus b?
Oh, yeah.
These are both written in, what do we call that form?
Slope.
What form is that called? Is that standard form or point slope or slope intercept? This is slope intercept because it's written so that you can read the slope and the intercept. So, from there, what does y equals mx plus b tell you? What does the m tell you? M tells you how you move, and b tells you what? Where you begin. So if we translate that into this equation, where do I begin? Where do I put my first point?
6. Negative 6.
Negative 6. So negative 6 is that up, down, left, or right 6?
Down and left.
Down. Okay? This is the y-intercept. So the beginning point is always on the y. Okay? Begin on y-axis. So we're going to put our first point at negative 6 on the y-axis. Okay, so down here. Put your first point at negative 6. Then from there, how do you move to get to your next point?
A half.
Move a half. So what does that mean?
Not all the way.
Not all the way. Not exactly. We always want to make it a fraction because remember, slope is rise over run. Okay, so m tells you how much you rise over how much you run, and we're always running to the right. So 1/2 tells you what? Go up 1 over 2. Up 1 over 2. So put a point right there. I want you to make a couple of points. So from there, again, go up 1 over 2,
Wait,
up 1 over 2. We're graphing this line.
Okay.
So the 1/2 tells us we go up 1 and over 2 to get to the next point. Then I get up 1 over 2. That's what the 1/2 tells us.
Okay.
So I just made a couple of points. Then I want to connect them with a line. And this is my pencil line, so I'm just going to connect them with a line. Okay, so draw that on your paper if you haven't done it already. Now we're going to do the same thing for my colored line. Okay, so you're going to use a different color. Where would I start my colored line? Where is its beginning point? At 3, and 3 on the what? Positive, and it's on the y-axis. So we're always starting the up and down. So put your first point at 3. What is the slope of this line?
Negative 4.
Negative 4, but I need to make it a fraction. So how can I make negative 4 a fraction?
4 over 1.
Over 1. So how does this one tell you to move? Go
4.
down 4 and over 1. Right, so from this point, count down 1, 2, 3, 4, and over 1. You have to put the 1 underneath, otherwise it would be a straight up and down line, and that's not right. Now, we're going to do the same thing, and I want you to make another couple points. So down from this point, you move down 1, 2, 3, 4, and over 1. What did you just notice? Did you just notice something when you made that other point?
I didn't even grasp this right.
This is where they're going to cross. So if you make a couple of points, you can see where they cross, right? So what would be the answer to this equation? Where do they cross? What point is this? I want you to count this point. So what point is this? Over 2, down what? 5. So if you have graph paper, you should use it, okay? On your homework, the grids are already on there. So it should be really easy to figure out where they cross. So this one crosses at over 2, down 5. Okay, so we always count how much we go over, then how much we go up or down. So over 2, down 5. That is where these two lines cross. So we would say this is the solution to your systems of equations.
Can we do one of those again?
We're going to do another one, yes. So basically, this is the only point that is on both of these lines. That's where they cross.
Without fractions. Can we do one without fractions?
The one without fractions, but most of them do have fractions. On slope, we actually like fractions.
I don't like.
Well, you have to make it a fraction even if you don't have one. We actually like fractions on these. Okay, this is one where we actually kind of like fractions.
I'll never like fractions.
Okay, well for this, it's actually a good thing to like fractions. Okay, let's try another one. Okay, let's find another one. Let's see. So, if I give you another one, okay, let's try another one for example number 2.
Wait, you still have fractions?
I don't know yet. I'm getting there. Thank you. Okay, example number 2. So I should see you guys paying attention, not being silly or whatever it is you might be doing. Sorry, I'm looking for another one that I like. Okay, let's try y equals x plus 3 and y equals no fractions. Negative 2x minus 3. Y equals x plus 3 and y equals negative 2x minus 3. So we're going to do, again, this is 2 different equations. So you're going to have one be a pencil dot and one be a color. Okay, or if you have 2 colors, that's fine. Okay, so, but it's important that you tell the difference between the 2. If you're doing both in pencil, then you have to label them to figure out which one is which. Okay, so that's why I like using different colors. So again, I'm going to put another grade on here. And like I said, on your homework, the grids are already on there for you. So you don't have to worry about this. So you don't have to worry about, like drawing them perfectly. So for my first equation, for this equation, what's my beginning point? Where should I begin my graph? Where do I put my first point? At 3. Is that up 3, right 3, down 3, or left 3? Up 3. We're always putting it on the y-axis, so up 3. Now, what's the slope for this equation? What number, what coefficient is attached to this x?
Wait.
A 1. But can I graph just a 1? I have to kind of make it a fraction, right? So it's 1 over what? 1 over 1. So you want to put that in there. So from this first point, how am I going to move to get to the next point? Up 1 over 1. Up 1 over 1. I want you to make a couple.
So will it always be up 1 over 1?
You're always going to, okay, we're going to talk about that right now. This one tells you up 1 over 1. So if I draw your equation or draw your line, it goes this way. Does that mean it doesn't go this way at all? Does your equation have to end right there? Or your line, do you think?
I need a professional grid.
No. Here, if I go up 1 over 1, up 1, right 1, that's actually the same thing as down 1, left 1. Okay? Down 1 would be negative 1. Left 1 is also negative 1. You don't have to write this part down. Down 1, left 1 is the same thing as up 1 over 1 because they're both equal to 1, right? So if you want to get some points going this way, you might have to go down and left. Okay, so say it again. Nope, this is still the same one. I'm still drawing the same one. So draw this line, try to make it as perfect as possible. Then we want to draw this line. So where's my first point? Where's my beginning point for this line? At negative 3. So negative 3 is down here at 3.
How many? Never mind.
Then how do I make this one? What's the slope of this line? Make it over 1. So how do I move to get from this point to my next point? Down 2 over 1. So down 2, right 1. Down 2, right 1. Okay, now if I want to make my line extend, how could I move? I can't move down and over anymore. How else could I move?
Up and left.
Up and left, right. So that's actually the same thing. So you could move up 2, left 1. Up 2, left 1. Okay, so I want you to understand that moving down and right is the same thing as moving up and left. Okay, down and right is the same as moving up and left. Now we want to figure out where do they cross. What point is the solution for this system? What point is this right here where they cross? How do we write this? We always move left or right first. So left 2, up 1. So these actually cross at negative 2, 1. So you're figuring out where do they cross each other. left 2, up 1.
I only got this first part.
Okay, so let's do the next one. So draw the other one.
What did you do?
Draw this other one. Y equals negative 2x minus 3. So draw that other one.
So up 2, down 1, up 2, down 1.
Yeah. Down, so you're going to start at negative 3. So put your first point at negative 3. We're doing our other color now. So put your other color. So put a point at negative 3. And then I want you to move down 2, right 1.
So this way?
Down 2.
Right here.
Down 2.
1, 2.
Right 1.
This way.
Yes.
Right here.
And then make sure you connect them. Right. Now connect them. And we want to figure out where do they cross each other. So you can connect it. Keep going. Yes. Thank you. You didn't count correctly. So up 2. Okay, each one of these should be like 1. So you did like goofy stuff here. So
I did.
up 2, right 1 is like right there. And another up 2, right 1. It should be crossing right there. Yeah.
Okay. So like this way?
Yes. So draw that.
Right here?
Now connect them all with a line. Okay. Are we ready to try another one?
How did we know it was negative 1?
So what is this point right here?
Negative 2.
Left 2, up 1. So that point is called negative 2, comma
Because
1.
it's right here at negative 2. And then
Because you go over 2, left 2, and up 1. So we name that point.
oh, okay.
Got it? Yeah. Okay, let's try another one. We're getting there, guys. We're getting there. Okay, let's try another one. For example, number 3. Okay, we're going to do the same thing. I want you to figure out, solve each systems of equations by graphing. Okay, I want you to solve by graphing. I should not be hearing talking right
This
now.
like number 1 and 2.
Very close, yes. If I give you the systems of equations, okay, system of equations, let's see, sorry, I lost my point. Y equals 1/4 x minus 1, and y equals 1/4 x. Y equals 1/4 x minus 1, and y equals 1/4 x. We should be writing this down, please. Y equals 1/4 x minus 1, and y equals 1/4 x. So again, we're going to have 2 different colors. So make sure you designate which one is which color. Then we want to either draw a graph or have a graph. So if you have graph paper, of course, yes, you can use that. If you don't, then we're just going to do our best to make nice graphs. So, where do you start the first line? Where should your first point be for this first line? At negative 1. And that's where x is negative 1 or y is negative 1. Where y is negative 1. So we're going to write it right here. That's the x-intercept. How do I move from this point to the next one? Darian, how would I move from this point to the next one? I'm doing this pencil line. So how do you move? What's the slope of this first line?
Wait, do we move up 1 over 4?
Yes. That's not what it's, yes.
Oh.
Okay, Chantal, how do I move?
Up 1 over 4.
Up 1 over 1, 2, 3, 4. Then I want to connect these with a line. Okay, so connect them with a line. So up 1 over 4. How about this one? What's the y-intercept of my second line? Remember, y equals mx plus b. These are in y equals mx plus b form. This is the form you always want to graph from. So your equation has to be in y equals mx plus b before we graph. The b is the y-intercept. That's where you begin. Where's the beginning point for this? So I just start nothing? 0, right? There's like an invisible plus 0. So my first point is at 0. From there, how do I move to get to the next point?
0.
How do I move? Up 1 over 4.
Oh.
Isn't that what I just did? I just did that, but they're different, right? Where do these two cross? What would be the solution to this systems of equations? They're parallel. So how many answers do you get here?
No solution.
So here, this means no solution. Okay, this means they will never cross each other.
Wait, can we write down parallel, no solution, or the same slope?
Okay, so the actual answer is no solution. But the reason they have no solution is because they're parallel. You know that they're parallel because they have the same slope. So if I gave you this question and I said solve by graphing, do you really need to actually graph? No, why? Because if you realize they have the exact same slope, they're never going to cross. You know they're never going to cross because they have the exact same slope. Yes, we're going to do another one. Okay, let's try another one for number 4. I'm going to give you guys some time to work in just a little bit, so you'll have plenty of time to talk, okay? So, next one, I would like you to solve by graphing again. Y equals 3x minus 2 and y minus 2x equals x minus 2. Y equals 3x minus 2 and y minus 2x equals x minus 2. Solve by graphing. So always, I want you to draw them in 2 different colors.
I lost my color.
So draw these in 2 different colors. So, are these in the right form to be able to be graphed?
No.
What form do I need these to be in?
Slope intercept.
Slope-intercept form. And slope-intercept form looks like y equals mx plus b. So, before you can start, change forms before you start. Okay? Change to y equals mx plus b before you start. How could I change that? Sorry. What do you have to do to get this in? Is this first one in the right form already?
Yeah.
Yes. This one is not though, so how do I get it into the right form? I need it to be in y equals, so the y has to be by itself. So how do I get the y by itself? Close. You want to add the 2x, right? So add 2x to both sides.
Wait, why are we doing that?
Because it's not in the right form. I can't graph it from this form yet. It has to be y by itself. So this would give you y equals what? 3x minus 2. Now, is it in the right form for me to graph? Yes. So now I can graph. For this first line, where's my first point? Where does my first point go? At -2. So put your first point at -2.
Now you gotta move
How do I move?
up 3 and over 1.
Right, we got to make this a fraction. So move up 3, so count up 1, 2, 3, and over 1. Remember, we're always moving to the right. Up 3, over 1. You probably need to make at least 3 points and then connect them with a line, just so that our lines are nice and straight. Yes.
You know how it's up 3 over 1?
Uh-huh.
Where does the over 1 come from?
We have to make it a fraction. Otherwise, if we just went up 3, we just keep going up 3, and that doesn't make sense. These are always going to have a slope.
Wait, we're starting at the purple one first or the top?
We're doing the first one right now. We're doing this one right now. So up 3 over 1. So draw your line. Now let's draw the purple one. The purple one, where should I make my first point? -2. How do I move for the purple one? How do I move for the purple one? Up 3 and over 1. And another up 3 and over 1. What are we noticing? It's the same line. So how many places do they cross? Infinite. They cross at here and here and here and here and here and every place. So this is called what? infinite solutions. So that means when we're trying to find the solutions, it's where do these two lines cross? And they cross at an infinite number of places. They're always crossing because they're the same line. Now, you wouldn't know that right from the beginning, though, because they were written in different formats. Who has questions about that?
I mean, Ms.
Yes.
Kuhn, hey, you know how we did like the plus 2x? How do we know that we need to do that?
Because before you can graph, it has to be in y equals mx plus b form. So y has to be by itself before you can graph it. So I'm telling you, y has to be by itself before you graph it.
So it says y minus 2x, the y isn't by itself.
Right, since the y wasn't by itself, we had to change it into a different form and get y by itself. Okay? You're going to see some like that, though. Okay? You will for sure see some, and that's the next thing we're going to do. Okay, for number 5, again, I want you to solve, and this one's going to say interpret the solution. Okay, solve and interpret the solution. Okay, let's do, sorry, I keep losing my place today. Okay, so for number 5, okay, now we're going to start a real world solution here, okay? So if I tell you Mrs. Kuhn bought 14 packages. Mrs. Kuhn bought 14 packages of red and green pens for a total of 72 pens. Okay, I bought 14 packages of red and green pens, and I had a total of 72 pens. The red pens come 6 in a package, and the green pens were 4 in a package. So they're not the same size, obviously. I want you to write and solve a system that represents, write and solve a system that represents the situation and interpret the solution. That one's kind of long, sorry. So write an equation that represents the situation and interpret the solution. It's most of what you're doing on your homework and on your test isn't just going to be graphing. You're going to have to write the equation and then graph it and tell me what it means. So it's a little bit more involved than just graphing. Okay, a little bit more involved, than just graphing. So I want to make sure that we can do that. So where do you think I begin here? What do you think we're actually going to be doing here? Any ideas? We're going to make an equation. How can I make an equation for this? You don't know. Let's think about it. How do you think I can make an equation for this?
Y equals 14.
Y equals 14.
X something, I don't know.
X and Y something. Well, yeah, it does have something to do with X and Y something. We don't know what.
Oh, Y equals 14. X plus 6 equals 4.
Not exactly. Any ideas? So we want to figure out how many red packages did I buy and how many green packages did I buy? How would you figure that out?
You bought 6 red packages, right? Or they came in 6?
They came in packages. Hi. Do you know whose this is? Thank you. Wait. Oh, is Kylie here? Oh, sorry. Yeah, this is yours, apparently. Sorry. I was like, hey, Lucas.
Is his name Lucas?
What's her last name? Her last name is Lucas. Don't worry about it. It's going to be okay. So, what do? I have, like, no idea what to do here. Someone help me out. What can we do?
I just told you.
No, you didn't. Okay, so we're going to make 2 different equations, okay? I'm going to say that x is equal to, which one? Do you want to make x equal to the red pens or the green pens? Okay, so we're going to say x equals the reds, 6 equals, or sorry, not 6.
Green.
X equals the red, y equals the green. So x equals red, y equals green. How many total packages did she buy? Did I buy?
14.
So this is about me. 14. So how would you write equals 14? How many total packages? How would you write that? Not y equals 14, but both of them together equals 14. So x plus y equals 14.
But doesn't the x supposed to be by itself?
We're going to get there. Then if the red pens come in 6, how would I write red pens are in 6? You would have to write 6x plus how many come in the green packages? 4y equals, how many total pens did I get? 72 pens. What you actually have to do here is graph these and figure out where they cross. Okay, so we actually have to graph these and figure out where they cross. Now, is this ever going to be negative? No. So when I draw my graph, do I really need a whole graph like this? No. Do I need really like the positive and the negative part? No. Okay, what you really need is just the positive part. So when we draw this graph, we can just draw a positive one. Okay, you don't have to include any of the negatives. Where do I start? Does anyone have any idea? Where do I start with this?
Up 1 over 14.
First thing we have to do is what? I have to change it to y equals mx plus b form. So how can I change this first one into y equals form?
Combine like terms.
Is there any like terms there? No. So how do I get this in y equals form? Subtract the x, right? So this becomes what form? How do I write that? Y equals what?
X plus 14.
Close. Okay, I'm going to rewrite this one down here. I'm going to move it a little bit so we can rewrite this. So this one will be 6x plus 4y equals 72. How can I get this y by itself? What do I have to do with the x? Subtract the x. So subtract the x from both sides. Yeah. So we get y equals, how do I write this? Should I write 14 minus x or negative x plus 14?
14 minus x.
Negative x plus 14 because I want it to look like y equals mx plus b. So I want the x part to be first. Now, is this in y equals mx plus b form?
Yes.
Yes. How can I get this one to do the same thing? What am I going to have to do? Start by moving the x, so move 6x, so subtract 6x. You subtract 6x, we get 4y equals negative 6x plus 72. Then what do you have to do? What do we have to do? Not subtract the 4, but how is the y attached to that 4? I'm going to add a post-it here. I didn't write this long enough, obviously. So 4y equals negative 6x plus 72. We said that, how do I get the y by itself? I just rewrote this. Divide both sides by what? By 4. So divide all the parts by 4. Okay, when you divide all the parts by 4, these go away. We get y equals what? What's negative 6 over 4? What does that reduce to be?
Can't we just use that for the fraction?
You can use it as the fraction, but you don't want to because it's like way too many spaces to count. So reduce this. This becomes negative 3 over 2x plus, what's 72 divided by 4? Ladies, it's not time to do hair. You need to be paying attention, please. What is 72 divided by 4? You might need to do it on the side of your paper. 72 divided by 4. I heard one person. 18, so plus 18. So that is your second equation. So I have one equation. Ooh, you okay?
Yeah.
One equation, 2 equations. We want to figure out where these two cross. So if I'm going to draw this, okay, if I'm going to draw this, and yes, you need to, how should I label these spaces? Do I really want to make 14 spaces up?
By 2.
You want to do by 2s? Okay, so let's do by 2s. So 2, 4, 6, 8, 10, 12, 14, 16. How far should I make my spaces this way? Should I go by 2s again?
Yeah.
Do you think we should go by 2s again? I think so. So 2, 4, 6, 8, 10, 12, 14, 16. So for my first line, where should I put my first point? For this first line, where do I put my first point? Where y is equal to what? 14. How do I move to get to my next point?
Over 1.
Negative 1 over 1. So down 1 over 1, down 1 over 1. So that means your next point could be here. My next point could be here. Okay. Connect them with a dot, or connect them with a line, excuse me. So down and over, down and over. Connect them with a line. Make it as straight as you can.
We're doing 14 over 1, down 1.
Yes, down 1 over 1. How about for this one? Where should I make my first point?
18.
At 18. Make my first point at 18. How do I move for this one? Down 3 over 2. Down 3 over 2. So from 18 you have to move to 15 and over 2. From 15 you move to 12 and over 2.
So on 18,
I'm listening.
We're moving 2 over 1.
Down 3 over 2. And 12, so you go to 9 and 6. So down 3 was 15, then 12, then 9, and you should be over to 6.
I got like spaces.
You got spaces.
Yeah, like wild spaces.
9, go down to 6 and over 8, right there. So, obviously it's a lot better if we draw these on a grid. Right? I apologize for not having a grid. So, where should these cross? Where do you think this point is right here? Over how many? 8. Over 8, up how many?
3.
Should be at 6. Okay? You want to use a grid on these. And that's why on your homework you're going to have grids. Okay? But my point here is you can have real life situations for these. You will have real life situations for these. Okay? What we're going to do now